Hi everyone, let's test our mastery. Let's find the t-intercepts now, the t-intercepts of y equals this thing over here. In other words, we want to find the real zeros or roots of g, where g of t equals this. The fraction, the square root of 3t squared minus t minus 4 all over t minus 3. To find the t-intercepts, we need to set y, this function rule, equal to 0. So when does this fraction equal 0? When the top is 0 and the bottom is not. In particular, 3 is excluded from the domain because it yields a 0 denominator. Now, you might be asking, well, wait a minute. What if the radicand here is negative? Aren't I in trouble? Yeah, but here's the thing. We're looking for cases where t is going to lead to a 0 value for the radicand. In order for the top to be 0, we need the radicand here to be 0. So we're only going to care about values of t that are going to make this radicand 0, and therefore the radical equal to 0 anyway. So don't worry about the values for t that'll make this radicand negative, because we're not looking for those values of t anyway. Now, actually, if we had a square root or fourth root down here, we might be a bit more worried. But no, the radical's on top. And again, even though the domain of g excludes values of t that yield negative values for this radicand, we don't care about those values anyway. We only care about the values of t that make the radicand 0 anyway. All right, bottom line. We care about the real values of t that will make the top equal to 0, but not the bottom. All right. So this fraction equals 0 if and only if the top, the numerator, equals 0, and the bottom does not equal 0. So the condition that t minus 3 cannot equal 0, that's equivalent to t not being equal to 3. We can add 3 to both sides of that equation. So if we get 3 as a tentative solution here, we better reject it. Let's see what happens. First of all, the square root of something equals 0 if and only if that something, that radicand, equals 0. Piece of cake. We can just remove the radical. Now, to find the real zeros here, it turns out that old school factoring will work. If you work out the discriminant, it'll be a perfect square. Old school factoring says we get 3t minus 4 and t plus 1. It might take some time for you to figure that out, but this is the old school factoring of this cutie. That product equals 0. Remember, t cannot be 3. We use the zero factor property, which tells us that this product will equal 0 if and only if at least one of these factors equals 0. So we set 3t minus 4 equal to 0, solve that for t. We set t plus 1 equal to 0, solve that for t, and we get 4/3 and also -1 as our real zeros for this quadratic, and therefore of this guy all the way up here. So the zeros of g, the real zeros of g, are 4/3 and -1. And they correspond to the t-intercepts. Remember, these are going to be t-intercepts. They're going to correspond to the t-intercepts 4/3, 0. T takes the place of x here. 4/3, 0, and -1, 0. If you don't believe me, let's use Desmos to get a graph of this. And we can use t.